Okay, let us talk about relative maximum and minimum of a function. Well, when we talk about maximum and minimum of a function, there are two types. One is called the relative maximum and minimum, which we will talk in a second. Another is called in fact absolute maximum or minimum, or sometimes they call global maximum or minimum of a function, which probably we will not talk. Anyway, the relative maximum or minimum means this. Well, the tallest person of a town, height of the tallest person of a town is the relative maximum. The tallest person in the town of Fort Kent does not mean that he is tallest in the state of Maine. Okay. So, we will be thinking of sometimes this relative maximum and minimum, they are called local maximum or minimum. So, let us see what do we mean. So, let us look at an example of a graph of a function and let us talk about the maximum and minimum of the function. So, let us say this is our x axis, this is our y axis. Let us consider a graph. Okay. Now, see, the function is increasing all the way up to this point, and then it starts decreases all the way up to this point. Again it start increasing and it increases up to this point and it again decreases. Okay, let us say x for this point is a, could be -1 or -2, I am just saying a for it. Let us say x for this point is b and x for this point is c. And let us say y for this point is let us say this is, I would say, y1. Let us say y for this point is y2 and let us say y for this point is y3. If this is the graph of a function, we say this: local or relative maximum is at x equal to a. So, this is the largest function can be around the neighborhood of a. Around the neighborhood of a, close to a, this is the largest the function can be. So, we say local or relative maximum of this function is at x equal to a, and the maximum value, the relative maximum equals y1. So, whatever is the y value is the maximum value. X value gives the location of the maximum and y value gives the maximum value of the function. X value tells us where it is, y value tells us the real maximum. In the sense of the height, x value tells us the name of the person, y value tells us the exact height. Okay. Now, if I look around B, this is the minimum. See, the function is not going any below than this point. So, I can say local or relative minimum at x equal to b, and the local minimum value this is equal to y2. And again, if we look further down, the function has another maximum at x equal to c, and the maximum value is y3. So, I can say again another local maximum is at x equal to c, and the maximum value at that x equal to c is y3. Well, now sometimes let's look at one more example here, or I'll not be using just symbol, I'll use some numbers. Let's say this function, let's say this is a graph of a function. Let's say this is y equal to 1 and this is y equal to 2 and y equal to 3. This is 0, let's say this is negative 1, this is negative 2, this is let's say 1, this is 2 and 3 and negative 3 and something like this. Suppose this graph is given. Looking over this graph, I can identify the local maximum is equal to 2. This is the maximum value, okay. This is the maximum value of the function at x equal to 0, and this function does not have any local minimum value, because if we think of the minimum value, this function is going down this way, and it's going down this way. So it goes down all the way down to negative infinity. So we don't have any local minimum. We might have realized by the two examples, a function can have multiple local maximum, can have multiple local minimum, can have no local maximum, no local minimum, or whatsoever. Our primary goal here should be this: given a graph, can we identify the local maximum and local minimum, and can we identify the x value and the y value corresponding to that. Y values are the real maximum, x value tells us the location where the maximum or minimum is.